Hello students, welcome to Anne's classes. Let's do Pythagoras Theorem, Chapter 18, the multiple choice type. Page number 221. Choose the correct answer from the options given below. So we have a figure here and we are asked to find the value of x, and the answer should be one of these options here. So look at the figure carefully. As you can see, this is a right angle triangle. Now let's name this for better understanding. So this is A, then let's name this as B and C. So here angle B is 90 degrees. So this is a right angle triangle. So we can apply the Pythagoras theorem here. So in that case, AC will be the hypotenuse. AC is the hypotenuse and that is given as 15 meters. Now we can apply the Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the square of the other two sides. That means AC square is equal to the sum of the square of the other two sides. One side is AB and the other side is BC. So when we square it up and add it up, then that will give us the square of the hypotenuse. So now let's substitute wherever we can. Now AC is already given to us. So that is 15 meters. So this is 15 square, which is equal to AB. Now AB is what we need to find out, x. So x square plus BC square is 12 meters. So 12 square. So now we can find the value of x square first. That will be equal to 15 square minus 12 square. So let's simplify this. X square is equal to 15 square is 225 minus 12 square is 144. So x square is equal to 81. When you subtract, you get 81. So now we can find the value of x. X is equal to the square root of 81. And what's the square root of 81? 9. Because when you multiply 9 twice, you get 81. 9 into 9 is 81. So the value of x is 9. And from our options, that is option 2, 9 meters. So let's write our unit here. So x is equal to 9 meters and this is our final answer. Question 2. A tree is broken at a height of 5 meters from the ground. So here we've been given a figure. We've been given all the measurements. So it's easy to understand. A tree is broken at a height of 5 meters from the ground. That means at this particular point. And its top touches the ground at a distance of 12 meters from the base of the tree, the original height of the tree. That is what we need to find out, and we've been given everything in the figure here, so it's easy to understand. Now, if we have to find the original height of the tree, we need to find the length of this portion from here to this part. We need to find the length and add it up to this. Now, as you can see, since you have two strokes here and two strokes here, this length is equal to this length. That means first you need to find this length. So let's name this now. So A, B, let's name this C, and here this point let's name it D. So now as you can see, B is 90 degrees. It's already given to us. So let's say angle B is equal to 90 degrees. That means we can take AC as the hypotenuse. So AC will be the hypotenuse, and then we can apply the Pythagoras theorem. So when we apply the Pythagoras theorem, we can say AC square is equal to AB square plus BC square. Now, if we find AC, it is equal to this measurement. That's why we are applying the Pythagoras theorem. So let's continue with this. So here we can say AC square, we can leave it as it is. So AC square is equal to AB square, which is 12 square, plus BC square, which is 5 square. So now AC square is equal to 12 square is 12 into 12, which is 144, plus 5 square, which is 25. So AC square is equal to 169. So what is the value of just AC? It is the square root of 169. So the value of AC is 13 because 13 into 13 is equal to 169. So we have found the value of AC. AC is 13 meters. So let's write it here now. Here we have AC. AC is 13 meters. That means this side also CD is also 13 meters. That means we can write it as AC is equal to CD, which is equal to 13 meters. So here also let's write 13 meters. Now we can find the original height of the tree by adding up this, that is 5 meters, plus this, which is 13 meters. So the original height of the tree, we can write it as is equal to BC plus CD. And BC is 12 meters and CD is 30. BC is 5 meters. I'm sorry about that. BC is 5 meters and CD is 13 meters. So now when we add it up, 5 plus 13 is 18. 18 meters. This is the original height of the tree. 18 meters, and that is option 3. 18 meters. Question 3. From a point P, a boy travels 12 kilometers due east. Okay, let's show that. So from a point P, a boy travels 12 kilometers due east. So we'll have a line drawn here. So the boy has traveled from this point east. So this is the east. So he moves that way. Then travels 9 kilometers due north to point Q. So from here, from this point, he's traveling up again to the north. So we draw a line there. So he has moved up to point Q. So this point here is point Q and he has moved in this direction. So here from P to this point here, he has moved 12 kilometers. So this is 12 kilometers. And from that point to Q, he has moved 9 kilometers. So let's mark this point here as R. So from P to R, it's 12 kilometers. From R to Q, it's 9 kilometers. Let's continue with the question. The shortest distance between the points P and Q. Now P is here, Q is here. Now if we go this way and this way, it's a long distance. So the shortest distance will be from here to here. So let's draw that line. So this is the shortest distance. Now this is what we are asked to find out. So PR is 12, RQ is 9. We have to find PQ. As you can see, this is a right angle, isn't it? This has formed a right angle here. That means at R, we have 90 degrees. So we can consider PQ to be the hypotenuse. So PQ is the hypotenuse, then we can apply the Pythagoras theorem and find PQ. So PQ is the hypotenuse. So now let's apply the Pythagoras theorem. According to the Pythagoras theorem, PQ square. So PQ square is equal to PR square plus QR square. Now let's substitute. Now PQ square we don't know, so we're going to leave it as PQ square. PR is 12, so that is 12 square plus QR is 9, that is 9 square. So PQ square will be 12 square, which is 144, plus 9 square, which is 81. So now let's add up this. So PQ square is equal to 225. When you add up both, you get that. Now we have to find only PQ. So PQ is equal to the square root of 225. So now we know the value of PQ. The square root of 225 is 15. So 15 kilometers. So the shortest distance between the points P and Q is 15 kilometers. And this is our answer, our final answer, 15 kilometers. And let's look at the options. The option here is option 1, 15 kilometers, which is our answer. Question 4, figures given to us, we have to find the value of x. As you can see, these two sides are same. That means if this is x, this is also x. Now let's name this figure. So we have A, B and C. A, B and C. At angle B, we have 90 degrees. That means we can take AC as a hypotenuse and apply the Pythagoras theorem. So AC is the hypotenuse. According to the Pythagoras theorem, we say AC square is equal to AB square plus BC square. So now let's substitute. So AC square, what is AC? AC is 10 root 2. Now the square of this whole thing is equal to AB square. AB is x, BC is also x, so x square. So this is going to be 10 root 2 the whole square. We can simplify this. 10 square will be 10 into 10. So that is 10 into 10 into root 2 into root 2. So this is equal to 2x square. Now again let's simplify. 10 into 10 is 100. So this is 100 into root 2 into root 2. So the root gets removed, that becomes 2. So this is equal to 2x square. Now we're going to find the value of only x square. So we're going to leave only x square here. On the other side, we already have 100 into 2. Now along with x square, what do we have? We have 2, isn't it? So this is multiplication. So when I take 2 away from x square and put it along with the others on the other side, this becomes division. So this is 100 into 2 divided by 2. Now what can we do here? We can cancel the 2's. So I can cancel 2 and 2. So what do we have here? X square is equal to 100. Now we can find the value of only x. X is equal to the square root of 100. And what is the square root of 100? 10, because 10 into 10 is 100. So we have found our answer. X is equal to 10. And let's go to the options. That is option 3. 10 is our answer. Question 5. Again, we've been given a figure here. We have to find the value of x. As you can see, x is here. Now, if you take this whole triangle, let's name it first. So here we have A, B, C. If you take the whole triangle ABC, it's going to be difficult to find the value of x because no other measurement is given, only for A, B and C. So we'll have to break this up into two triangles. So let's name this point as D. So the point here in between, we will name it as D. Now we can take the two triangles ABD and ADC. Now if we have to find the value of x, because this is a right angle, we can use the Pythagoras theorem. We need to find the square of this and the square of this side AD. But since we don't have the square of AD, we're going to find out with the help of this triangle the value of AD and then use the second triangle. So this is going to be the first triangle that we're going to work at, and then second triangle to find the value of x. So let's begin by saying in triangle ADB, okay, let's take that. In triangle ADB, angle D is equal to 90 degrees. So if angle D is a 90 degrees, then AB is the hypotenuse. Okay, so let's write that. So AB is the hypotenuse, so we can apply the Pythagoras theorem. According to that, AB square, that is AB square, will be equal to BD square plus AD square, AD square. Now let's substitute. Now AB we already know is 10, so that is 10 square is equal to BD, also we know it is 6 square plus AD. Now we don't know AD, so we're going to leave it as AD square. So now to find the value of AD square, we say it's equal to 10 square minus 6 square. So AD square is equal to 10 square is 100, 6 square is 36. So AD square is 64. Now we can find the value of AD. AD is equal to the square root of 64. And we know the square root of 64, which is 8, because 8 into 8 is 64. So we have found the value of AD. Now we look at the figure. AD is 8. We can write it there. So AD is 8. So now we can look at this triangle ADC and find the value of x. So let's do that. in triangle ADC. So this time we are taking triangle ADC. In this again, angle D is equal to 90 degrees. So we can take AC as a hypotenuse. So AC will be the hypotenuse and we can apply the Pythagoras theorem. So according to the Pythagoras theorem, the hypotenuse square, that is AC square, will be equal to DC square plus DA square. Now let's substitute. AC square, we don't know it is x, so x square is equal to DC. DC is 15, so 15 square plus DA. DA is 8, 8 square. So now let's simplify this. X square is equal to 225 plus 64. That means x square is equal to 289. Now, to find the value of x, we say x is equal to the square root of 289. And what is the square root of 289? It is 17. So, we have found the value of x. When you multiply 17 into 17, you get 289. So, 17 is our answer. And in the options, that is option 4, 17. This is our answer. Question 6. From this figure, we need to find the value of x. So x, as you can see, is here. So we need to find this whole length of this figure. So let's name this first. So this will be A, B and C. And let's name this part as D. So here, how do we find the length of x? First, we need to find the length of AD. Then we need to find the length of BD and add it up. So here, since we have right angles, we can use the Pythagoras theorem. So first, let's look at the triangle ADC. So let's write that. In triangle ADC, angle D is equal to 90 degrees. So in that case, AC will be the hypotenuse. AC will be the hypotenuse. So AC is the hypotenuse, and according to Pythagoras theorem, AC square, that is the hypotenuse square, is equal to AD square plus CD square. So now let's simplify this by substituting. AC is already given to us. AC is given to us, it's 10. So AC square means 10 square is equal to AD, we don't know. We'll leave it as it is. CD is given to us, it's 8, so 8 square. So now let's find the value of AD square. AD square is equal to 10 square minus 8 square. So let's simplify. AD square is equal to 100 minus 64. So AD square is how much now? AD square is equal to 36. We want to find only AD. That means we will write the square root of 36. And the square root of 36 is 6 because 6 into 6 is 36. So we have found the value of AD, this portion alone, and that is 6. Now we need to find the value of this part now, BD. So we can add up the AD and BD and find the value of x. So now we're going to take triangle CDB. So in triangle CBD, angle D is 90 degrees. So we can take BC as the hypotenuse and apply the Pythagoras theorem. So BC is the hypotenuse, and according to the Pythagoras theorem, we can say BC square is equal to BD square plus CD square. Now let's substitute. Now BC is 17. So we can say 17 square is equal to BD. BD, we don't know what it is, so we'll leave it as BD square plus CD. CD is 8, 8 square. So now to find the value of BD square, we say 17 square minus 8 square. Now 17 square is 289 minus 8 square is 64. So now BD square is equal to 225. That means we know the value of BD. BD is equal to the square root of 225, which is 15. So BD is equal to 15. Let's write it there in the figure. So here we have 15. So now we're going to find the value of x. X is equal to AD, the length of AD, plus the length of BD. So AD is 6 and BD is 15. So the value of x is equal to 21. 6 plus 15 is 21. This is our answer, and that is option 1, 21. Question 7. Question 7. The perimeter of the quadrilateral or rhombus ABCD is what we need to find out. So here we have the rhombus. All four sides are equal and there are two diagonals here. Diagonals of a rhombus bisect each other. So that we have to remember, diagonals of a quadrilateral or rhombus bisect each other. Now here, as you can see, when we say bisect, that means we're going to divide both sides into two equal halves. So here the whole measurement is 8 centimeters. That means this half from O to A is 4. This will be 4 centimeters and the other side will be 4 centimeters. Similarly, the whole thing is 6 centimeters. So this will be 3 centimeters and this side will be 3 centimeters. So that is how the diagonals are bisecting each other. The whole length is 6 centimeters. Now we are asked to find the perimeter of this quadrilateral. Perimeter is when you simply add up all the sides, and since the sides are equal, you just have to say 4 into one of the sides. Now how do we find the sides? So what we're going to do here is we're going to look at triangle AOB. So in triangle AOB, you can see that this part, that is O, is 90 degrees. Angle O is 90 degrees. So let's first write in triangle. We're looking at triangle AOB. There are many triangles. We're looking only at this triangle. So look at that, AOB. This triangle we are looking at. Now here, since angle O is 90 degrees, let's write that angle O is 90 degrees. Then in that case, the side that is opposite to the 90 degrees will be taken as the hypotenuse. Now AB is the side that is opposite angle 90 degrees. That means this is the hypotenuse. So we can say AB is the hypotenuse. Then to find AB, we can use the Pythagoras theorem. So according to the Pythagoras theorem, we can say AB square is equal to OA square plus OB square. So let's write that AB square, that is the hypotenuse square, is equal to OA square plus OB square. Now we just have to substitute. Now AB we don't know. That is what we need to find out. So we leave it as AB. AB square is equal to OA. Remember, OA is here and that is half of 8 centimeters, which is 4 centimeters. So OA square, we will write it as 4 square plus OB. Now how much is OB? OB is half of 6 centimeters, which is 3 centimeters. So that is 3 square. 3 square. So AB square is equal to 4 square is 4 fours are 16 plus 3 square is 9. So AB square is equal to 25. Now we have to find only AB. AB is equal to the square root of 25. That means the value of AB is equal to 5. So AB is 5 centimeters. So let's write it in the figure. So this is 5 centimeters. So if this is 5 centimeters, then all four sides are also 5 centimeters. So let's write that perimeter of the quadrilateral is, now you can say AB plus BC plus CD plus DA, or you can say 4 into side and multiply this side. Okay, so we can do it any one of the ways. So let's write AB plus BC plus CD plus DA. And AB is 5 centimeters. They're all 5 centimeters each. So we add it up 4 times. plus 5 centimeters. Now when you add it up 4 times, you get 20. So 20 centimeters. So the perimeter of this quadrilateral is 20 centimeters. This is our answer. Now let's look at the options that we have. And in the options, as you can see, 20 centimeter is not there. So our answer is none of these, and that is option 4. So this is our answer. Question 8. The perimeter of quadrilateral, that means the rectangle ABCD, is which one here? So this is our rectangle and we have certain markings here. Here can you see it's 8 centimeters. The diagonal is 10 centimeters. Now we know in a rectangle the opposite sides are equal. So if this is 8 centimeters, the opposite side is also 8 centimeters. So this is 8 centimeters. Now we have to find these two sides. So remember, the perimeter will be when you add up all sides, or if you know the formula for perimeter for rectangle, you can apply that formula. So here first let's write what's given to us. Now here we have been given AB. Now AB we know is equal to CD, and that is equal to 8 centimeters. Now let's look at triangle ABC. This part, because the rectangle has been cut by this diagonal AC, so we have two triangles here. So let's look only at triangle ABC. Can you see at B we have a 90 degree here. Remember, for a rectangle all angles will be equal to 90 degree. So let's write that also. Angle B is equal to 90 degrees. That is in angle ABC. In angle ABC, angle B is 90 degrees. So let's mark that in the figure also. So this is 90 degrees. That means the side that is opposite the 90 degrees is AC, and that is the hypotenuse. So hypotenuse is AC. Now we need to find this side, that is side BC. If we find side BC, then this is also the same because both are opposite sides. So to find side BC, we can apply the Pythagoras theorem. According to that, AC square is equal to AB square plus BC square. Let's write that. So AC square is equal to AB square plus BC square. And let's substitute. AC is 10 centimeters. So we can say 10 square is equal to AB is also given to us 8 square plus BC square, which we don't know. So we will write it as BC square. So now we're going to find out BC square. So that will remain as it is. On the other side we have 10 square. We are moving 8 square, so it becomes minus 8 square. Now let's find out BC square, how much it is. That is 100 minus 64. So BC square is equal to 36. This is BC square. That means how much is BC? BC is equal to the square root of 36. The square root of 36, and that is equal to BC is equal to 6, because 6 are 36. So BC is 6 centimeters. Now let's write that there in the figure. BC is 6 centimeters. That means the opposite side is also 6 centimeters. Now we can find the perimeter of this rectangle. So perimeter of the quadrilateral, which is a rectangle, is simply adding up all the sides, that is AB plus BC plus CD plus DA. So let's substitute. AB is 8 centimeters, BC is 6 centimeters, CD is 8 centimeters, and DA is 6 centimeters. So let's add this up. 8 plus 6 is 14. 14 plus 8 is 22. 22 plus 6 is 28. So we have it here, 28 centimeters, and this is the perimeter. So we have found the perimeter of the rectangle, and the perimeter of the rectangle is 28 centimeters, and in our options it's option 3, 28 centimeters. Question 9, we have to find the length of BC. So in this figure, you can see BC here. Now what is given to us? We've been given two angles and two sides, and we have to find this side, the third side. Now since angles have been given to us, we have to make use of those angles. So we have been given two angles. Let's find the measurement of the third angle. So 40 plus 50 plus, let's call angle A as the unknown angle. Angle A is the unknown angle. So that means angle A plus angle B plus angle C. All this should be equal to 180 degrees. Why is it so? We know that sum of angles of a triangle is equal to 180, or we call it the angle sum theorem. That means the sum of angles of all of a triangle should add up to 180 degrees. Now let's substitute and find the value of angle A. So here angle A we don't know, so it remains as it is. Angle B is 40 degrees and angle C is 50 degrees. And all this should add up to 180 degrees. So to find angle A, we say angle A plus 90 degrees is equal to 180 degrees. That means angle A will be equal to 180 degrees minus 90 degrees. So we have found the value of angle A. Angle A is 90 degrees. So let's mark it there in the figure. So in the figure, this is 90 degrees. So we've got angle A that is 90 degrees. Now, since angle A is 90 degrees and we need to find this side, we know that the side that is opposite the 90 degree is the hypotenuse. That means BC is the hypotenuse. So angle A is 90 degrees. That means BC is the hypotenuse. So we can apply the Pythagoras theorem. According to the Pythagoras theorem, the hypotenuse square, that is BC square, is equal to AB square plus AC square. AC square. Now let's simplify this. BC is what we are going to find out. So BC square is equal to AB is 16. 16 square plus AC is 12. 12 square. So now let's find BC square. BC square is equal to 16 square, which is 256, plus 12 square is 144. So BC square is equal to, you add up 256 and 144 and you get 400. So BC square is 400. That means BC is equal to the square root of 400. And from this we can say that BC is equal to, square root of 400 is 20, because 20 into 20 will give us 400. So this is 20 centimeters. So we have found the length of BC and that is 20 centimeters. So this is our answer. And which option is this? This is option 4, 20 centimeters. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.